Solving radical equations and inequalities. Radical equation is an equation that contains a radical expression with the x variable or the independent variable inside the radical, which we call the radicand. The way I'm going to show these is just by working through some equations with you, and then I'll work through some inequalities, and then it really is just using inverse operations, and then kind of knowing a few things that you have to be aware of. So we're going to go through these, so maybe try them before I try them, and then see how you do, and then check your work with me. So this first one here, 2 equals 5 times the root of x minus 3, all minus 18. I'm just going to separate the equation. I'm going to go ahead and move everything outside of the radical first to the other side. Move it away from the radical, so add 18 and add 18. I won't show my steps on all of these, but on this first one I will. Okay, so 20 is equal to 5 root x minus 3. And then since they're multiplying by 5, I'm going to go ahead and divide both sides by 5 to undo that right there. And it gives me 4 is equal to the root of x minus 3. And then to get rid of that radical, I'm going to, since it's being raised, or it's the square root, I'm going to go ahead and raise both sides to the second power. They undo each other. That gives me what's in the radical, x minus 3, those cancel, is equal to 16. And then I've got to move that 3 by adding 3 to both sides. So x is equal to 19. Okay, and then you can check your work. You can put the 19 in. 19 minus 3 is 16. Root of 16 is 4. 4 times 5 is 20. Minus 18 is 2. So it works out. Okay. Now the next one, 4 is equal to, 4 is equal to the cubed root of x plus 2, all plus 8. So once again, I'm going to move the 8 first. So subtract 8 from both sides. I end up with negative 4 is equal to the cubed root of x plus 2. Now I've got to get rid of this cubed root now that it's all by itself. So the opposite of cubed root is to cube something. So we raise both sides to the third power. That cancels that. We get 4 times 4 times 4, which is 64, and negative times negative times negative, which is negative. And that gives me x plus 2. Okay. One thing to keep in mind here, I should have pointed out, is when I got the cubed root, we'll write it over here. When we got negative 4 is equal to the cubed root of x plus 2, just remember it's okay for an odd root to equal a negative. Now if this was an even root, that would be a no solution at that point, because you couldn't have a root, no matter what's inside of it, equaling a negative if this is an even number. But since it's odd, we're okay. Okay? So we're okay with that because it's odd. All right. We'll erase that there. So next step, subtract 2, we get negative 66 is equal to x, and we are done. Negative 66 plus 2 is negative 64. The cubed root of negative 64 is negative 4, and then we'll add 8, which will give us positive 4. So it works out. All right, the next one, x is equal to the root of x minus 3, all plus 3. So when you have x on the outside and the inside, it's a little different there, just a little more complex, but still want to get the radical by itself first, so we'll subtract 3 from both sides. So I get x minus 3 is equal to the root of x minus 3. Have to get rid of the root now, so I'll square both sides. And now I'm squaring both sides means I'm squaring everything in that, so I've got to put it in parentheses. This cancels this. I'm now left with x minus 3 here, but on the other side I'm left with x minus 3, quantity squared. Now remember, x minus 3 quantity squared means x minus 3 times x minus 3, which is actually x squared minus 6x plus 9. Right? So if you're like, huh? I'm doing that right there. Okay, so that's going to be the next step. I'm going to actually multiply that out. So I get x squared minus 6x plus 9. And I do that so I can actually move this 3 and this x over. All right. So since I have a quadratic, I want to set it equal to 0, see if I can factor it. So I'm going to go ahead and add x. Not add x, excuse me. Subtract x and add 3. All right, and so we'll subtract x and add 3. That gets 0, that gets 0. So on this right side, we're left with 0. On the left side here, we're left with x squared minus 7x plus 12. Okay, And now we can look at factoring or use quadratic formula, whatever we need to. In this case, two things that multiply to make 12 and add to 7 are -4 and -3. Okay, so it does factor. And x minus 4 is equal to 0. Right, using the zero product property, that's x equals 4. And x minus 3 equals 0. That's x equals 3. So x equals 4 and 3. Test them out, 4 minus 3 is 1, root of 1 is 1, plus 3 is 4, good. And then 3 minus 3 is 0, plus 3 is 3, and 3 equals 3, good. So we're good, they both work out there. Okay, let's go ahead and try another set here. Extraneous solutions, when each side of the equation is raised to the same exponent, or and solutions are introduced that are not solutions to original equation, we call those extraneous. In other words, if you say like square both sides, sometimes you get an extra answer in there, or you get an impossible situation. Okay, so let's check this out. The root of x is equal to -8. So if you didn't, let's say you just didn't realize, hey, square root can't equal a negative. So you're like, okay, I'm just going to square both sides. All right, seems logical. All right, and so that would give me x. All right, those would cancel. Is equal to, well, -8 squared is 64. So you go, all right, x is equal to 64, so I'm good to go. Well, if you check that, okay, so to -8, which we know is not true. The square root of 64 is not equal to -8. The square root of 64 is equal to +8. So these are not equal. This -8, or this 64, excuse me, is extraneous. All right, so sometimes when you're raising each side to a power, to some exponent, you're going to get those extra answers in there. So what we do, we just make sure we check our work. All right, so let's go ahead and try when we solve this equation. And let's see if there are any extraneous solutions. So the first step, I'm going to go ahead and square both sides. Okay, and just like we did a minute ago, there's going to be a binomial squared, which is x squared plus 6x plus 9. And this cancels this, so -5x plus 21. Okay, I want to go ahead and move everything over because I have a quadratic. It's not going to cancel out, so we'll add 5x over. That gives me 11x. We'll subtract 21 over. That gives me -12. And we still have our x squared. Okay, and all that equals 0. So now we look to factor. Well, if we can, in this case we can, we get x plus 12 and x minus 1. Which gives us two solutions. It gives us x is equal to 12, right, or -12 right here. And x is equal to +1 right here. So those are our two solutions. All right. Well, what we should do is test them. So let's check them out. We'll plug the 1 in. Okay, so over here, I'm going to actually show the checks this time. So I get 1 plus 3 is equal to -5 times 1 plus 21. Okay, we get 4 is equal to square root of -5 plus 21, or square root of 16, which actually does equal 4. So we're good. This one works. All right. Try the next one. X plus 3 equals square root of -5x plus 21. Put in that -12. -12 plus 3 is equal to square root of -5 times -12 plus 1. Okay, whoa. Don't want that. All right. We end up on this side. Well, we get -9 is equal to square root. Now, right away, you should look, whoa, hold on. Square root cannot equal negative. This is even. Can't be negative. That does not work out. Now, you could keep going. Like if you kept going, you didn't realize that, you'd end up with that right there. You get -9 is equal to the root of 61. I don't know why that keeps switching on me. Probably the way I'm dragging my pen. Okay, so that does not work out. All right, the root of 61 is definitely not negative 9. Square root can't equal a negative anyway, so this one is extraneous. So we just cross it out and say our answer is x equals 1. All right, let's check another one here. The root of 2 x minus 5 equals 1 minus the root of x minus 3. All right, so first step, sorry about that. First step, I'm going to square both sides. Okay, so there and there. Okay, this cancels that. So I'm left 2x minus 5. And, well, this is a binomial. I know it looks weird, but it actually is a binomial. It's the same thing as like having a minus b squared, right? So you have 1, so like 1 would be your a, and this would be your b right here. Let's put a big B just to kind of cover the whole thing there, like a minus b squared. Okay, so you have a binomial squared. So if that kind of freaks you out the way you see it, I'm sorry, but that's what it is. Okay, you could rewrite it like this to make it look a little easier on yourself. Okay. So it looks like that. Now, if your next step here is to actually multiply that out, right? So can't do anything until we multiply it out. So we get 1, and then we get 1 times negative x, the root of x minus 3, so that's negative root x minus 3. And then 1 times negative root x minus 3, so once again that's minus root x minus 3. And then negative root x minus 3 times negative root x minus 3, which is actually positive root x minus 3 squared. Okay? And then you still have this 2x minus 5 that's just kind of tagging along for the ride. Okay, so we have 2x minus 5. And on this side, the right side, we have 1 minus 2 times root x minus 3. And then when you square a root, you get what's in there, so you get plus x minus 3. All right, so I look at this and I see I have a radical again. So I'm going to go ahead and move everything away from the radical again. So I'm going to move everything to the left side except for the radical. Okay, well, the radical and then 2 that's attached, but I'll explain that here in a minute. So I'm going to go ahead and move this 1 over, subtract 1. I'm going to move that 3 over, add the 3, and move that x over, subtract the x. Okay, so I'm subtracting the x, I'm subtracting a 1, and I'm subtracting a 3, which if you wanted to, you could have put the, or I'm sorry, I'm adding a 3. You could have put the 1 and the 3 together on the other side. Whichever route, you know. Anyway, this gives me x. 5 minus 1 is, negative 5 minus 1 is negative 6 plus 3 is positive 3. So I'm left with x plus 3 over there. And, oops, I'm sorry, that would be a negative 3. X minus 3 over there. And negative 2 root x minus 3 here. So notice now, I could divide by 2, but it would give me an ugly fraction here. What I'm going to do is I'm going to square this whole side. I'm going to square this whole side. Okay. Now, when you're squaring a product, really you're squaring both parts in, right? So if you think back to your properties of exponents here, like if you had a times b quantity squared, you'd square both in. Well, that's kind of what you're doing here. Here's negative 2 would be a, and the root would be b. Okay. So I'm left with positive 4 is equal to, well, x minus 3. So I have to put that in parentheses there because you're multiplying this thing by that. When you bring it out of the radical, you have to put it in parentheses. And squaring this gives me x squared minus 6x plus 9. I dealt with that a little earlier, actually. Okay. I now have a quadratic. I'm going to go ahead and bring this in. So rather than writing all that out, just going to do that. Okay. Actually, I will go ahead and put x squared minus 6x plus 9. Okay, and I'm going to move the 4x by subtracting 4x. So now I have x squared minus 4x is minus 10x. And I'm going to add that 12 over, so plus 21 is equal to 0. So now solving for x, trying to factor, well, I get x minus 3 and x minus 7. Well, what does that mean? Let's put it over here because I'm running out of room. X is equal to 3, and X is equal to 7. What I need to do is I need to check my work. So I'm going to erase that there so I have some room. Okay, so I switch screens again. So erase that little mark in there, and there we go. Okay, so let's go ahead and put these in here. So I have the root of 2 times 3 minus 5 is equal to 1 minus root of 3 minus 3. Well, what's that give me? Well, that gives me the root of 6 minus 5, or 1, is equal to 1 minus the root of 0. So in other words, 1 equals 1. Good to go. Okay, so 3 works. We'll go ahead and put in our 7. So now I have the root of 2 times 7 minus 5 is equal to 1 minus the root of 7 minus 3. Well, that's 14 minus 5, also known as 9. So the root of 9 is equal to, well, that is 1 minus the root of 4, and that means 1 minus 2, which means 3 is equal to 1 minus 2, or negative 1. That is not true. Therefore, this one, the 7, is extraneous. All right. The answer is x equals 3. Okay, so we've had some tougher problems there, especially dealing with this binomial that kind of looks weird. Let's move away from radicals and move on to rational exponents. Okay, if we're dealing with these rational exponents, so you may want to take a breather here. All right, in class this may be like a day 2 piece, I don't know, depending on the day. All right, so we're going to go ahead, kind of treat it the same. I'm going to think of this as like your radical piece, this 27x to the 3/4. I'm going to move that 1 over first by adding 1. So I get 27 is equal to 27x all to the 3/4. Now really, when you're trying to get x by itself, what you're doing, if you think of just x, actually let's put it at the bottom here. When we're thinking of x equals, right? We're thinking of x to the first power. So you want x to be to the first power. And right now, if you were to bring that 3/4 in, x is to the 3/4 power, which we don't want. So the way we get rid of that power is we make it a first power. So what could I multiply 3/4 by to get 1? Well, the answer is the reciprocal, 4/3. Okay, so you raise both sides to the reciprocal power, 4/3 power. That cancels that, and that cancels that. And I'm left now with 27x, which is good. X is to the first. Now you have this radical over here. And remember, 27 to the 4/3, if it helps you think of it like this, that means 27, means the cubed root of 27 all to the 4th. Now it's nice if the cubed root, if like 27 is a perfect cube, which it is, that means you have 3 to the 4th. Cubed root of 27 is 3, and 3 to the 4th is 81. So what we have, not x equals 81, but we have 81 is equal to 27. You know what, that x to the first is cramping my style there. So let's fix that up. Okay, 81 is equal to 27x. All right, and now we can divide by 27. So x is equal to 3. And you should check your work. You plug that 3 in there. It does check out, so I'm not going to work us through our checks every time, but here we go. So let's try another one here. At the 1/2 power, notice it's already by itself, so I'm going to go ahead and multiply that power by its reciprocal of 2, and which means really what it means is I'm raising this whole thing. I know I show it like just multiplying with it, but it means you're raising that whole thing to the 2nd power. And these just cancel. 2 halves make a whole. Okay, so you're doing the same thing there, which gives us an x squared, which if you really look at that, and we'll show it here in a minute, you get 12x minus 27. When you see that x squared, you should be going, oh man, I got a quadratic, which means, yep, you're going to have to use one of your tricks to solve quadratics, but get it set equal to 0 first. So subtract that 12x over, add that 27 over, Now look to factor if you can, or use the quadratic formula, or factor, or not factor by grouping, but completing the square. Okay. In this case, factoring works well. X minus 9 and x minus 3. So x is equal to 9 right here, and x is equal to 3 here. You should check your work. You plug them back in. 3 12s, 36. 36 minus 27 is 9. Root of 9 is 3. We're good. 12 nines is 108. 108 minus 27 is 81. The root of 81 is 9, so we're good. They both work out. All right. Yeah, I don't have any more of those. So I'm going to go ahead and move on. Solving radical inequalities. And these you just really solve just like you would the equations. I mean, remember if you multiply or divide by a negative, switch the direction of the sign. Okay. So let's go ahead and try one of these here. Square both sides here. Okay, I'm left with 5x plus 4 is equal to, or not equal to, is less than or equal to 64. Subtract 4. Get 5x is less than or equal to 60. Divide by 5. X is less than or equal to 12. Okay, so we got 12 as a solution. Now one thing you have to focus on here is what's called considering the radicand. When it is an even root. Okay, remember an even root, you can't have a negative number inside an even root. So this is an even root, it's a square root. So that means 5x plus 4, the thing inside the root. So if we're highlighting this thing right here, I'm putting right here, and I know that that thing cannot be negative. And if it cannot be negative, that means it has to be bigger than a negative number. Okay, which means it has to be greater than or equal to, it could actually be 0, but it can't be any less than 0. So when you're considering the radicand on an even root, you've got to do one more step here. Subtract, you've got to solve the second inequality. Subtract 4, divide by 5. So you have two things here. You have x has to be less than or equal to 12, and x has to be greater than or equal to negative 4/5. So that means x, I'm going to go ahead and write it here, x has to be between negative 4/5 and 12. So we literally put it between those two. And there we go. And there we go. All right. I'm going to switch colors to, didn't mean to switch slides, switch colors to help us out on this next one here. Okay, so next one here, we're going to go ahead and add 5. All right, so we get 2 root x is greater than 10. Divide by 2, root x is greater than 5. And take the root, or excuse me, square both sides. Get x is greater than 25. All right, so x has to be bigger than 25. Now, is it an even root? It is, however, I mean, the rule here would be x also has to be bigger than or equal to 0, right? The thing on the inside has to be greater than or equal to 0. So we can write that right here, consider the radicand. Okay, however, no, it already says x has to be bigger than 25. So if x is going to be bigger than 25, there's no way it's going to be smaller than 0. So we don't have to put that second piece. We can just leave it at that. That kind of takes care of it. We are okay. All right. Let's do the last one here. And I'll switch colors again. Okay. Well, we'll start by dividing by 3. Okay, so we get the cubed root of x plus 1. We divide both sides by 3. That gets rid of the 3 there and makes this 4. Raise each side to the third power. This is 64 on the right and x plus 1 on the left. Subtract 1, x less than 63. Don't have to consider here. Remember, with an odd root, you can have a negative on the inside and no problem. So don't have to consider the radicand on an odd root. Okay, I think that's all I've got for you. Good luck.